Alright, hey, what's up? How's it going? It's April 13th, 2021. The day is approaching when we'll have received all the CS knowledge in the world through a direct mind transfer from me. If only that was possible, but maybe one day. So, with that being said, it's time for a new coding problem. So, let's start with 1207, a unique number of occurrences. So interesting. Liked by 666 people, disliked by 26 people. This must be, I'm the type of person to look into prophesization and science stuff, biblical stuff, stuff like that. And when I look at this, I think, well, yeah, this is interesting because anyway, I'll get into that later. Let's just get on with the problem. Alright, so if you like this video, subscribe, and comment in the link below, okay? And that helps me make more of these. So let's get on to it. Given an array of integers r, write a function that returns true if and only if the number of occurrences of each value in the array is unique. Okay, so what does that mean? Alright, let's take a look at the example. You have 1, 2, 2, 1, 1, and 3. So every occurrence of a unique value, the number of occurrences of each value is unique, meaning there's 3 1s, there's 2 2s, and there's 1 3. Okay, so just take a second to wrap your head around that. Not too complex of ideation. In this case, 1 and 2 is false, right? Because both 1 and 2, even though they're unique values, they both have a count of 1. Okay, so what are some ways we can tackle this problem? And obviously, you can take a look at this, and you can see another one. And then, you have your constraints. So what are some ways we can tackle this problem? So as soon as you see maps, you should think right off the bat counts, right? Okay, so let's get our maps going. So what do we need to do here, by the way? We need to figure out not only what the unique values are, right? But we need to find out whether the counts themselves of the unique values are unique. So what I'm going to do is I'm going to start with a hash map to get the counts. Okay. Now you can use a hash map, or you could use some other data structure like an array. In this case, I'm going to opt for a hash map because I have something in mind that I want to do. So firstly, I want to get the count. So this is a standard operation, right? You want to do this in a pretty fast clip. So hash maps are perfect because you can get O of 1 operations. You can get the count of something very easily, an integer or an integral number or some kind of number. You get or default, my favorite function, ARI 0 plus 1. Okay, so what am I doing here? I'm trying to just get the count of each of the numbers. So if I was to output the result of this, I would see that, well, let's just take a look at the result. I'm just going to show you the result by running the code. Okay. Now this isn't the whole answer, mind you. This is just the count portion. So if you take a look at the count of the test case, you see there's 3 3s, 2 2s, and 1 1. Now what's a good way to tell whether each of these is unique? Okay, well, you guessed it. Remember, the counts are unique, but how do we know, and how do we know fast? Well, what you could do is we could, we could do all sorts of things. We could sort stuff. We could do a brute force counting and just look at the difference between all the numbers. We don't want to do that, right? We want to do something more intelligent. So what I'm going to do is going to put down another hashing data structure, hash set equals new hash set. So this is going to quickly return to me whether my counts are unique. So for integer key map.keyset set.add map.get key return set.size equals map.size. And why did we do this? Well, okay, so this is going to be pretty much, this should give me my answer, all right? And why? Because now I'm just, this is the trick. If the number of keys is equal to the number of unique values, right, then I know my answer is true. So how do I know that? Okay, well, there are 3 unique values. We saw in the last test case. In here, there's one unique value for 3. There's three values for 1, and there's 2 values for 2. Okay, so that should equal that count of 1, 2, 3. There should be a unique count for each element. If there's a unique count for each element, that means each element is going to be a one-to-one correspondence with a unique count. Do you understand? So it's always going to be the case where A, B, C is going to equal a distinct count X, Y, Z. Okay, or like you can call it C1, C2, C3, where none of them are equal. Because if C1 is equal to C2, for instance, then that fails the case because there's 2 counts which are the same. All right, so let's run this. And again, this is done for a quick lookup. Run code. True. Submit code. And all right, pretty good. 99.76% faster. 36.8 memory. Yeah, so I guess because we used 2 hashing data structures, it was a little less efficient space-wise. But you know what? You know, we have a fast algorithm, all right, and we can probably optimize it for space. All right, so well, that being said, I want to bid you a fair adieu as you listen to Beethoven, and I will talk to you again. Remember, like, subscribe, and show me some love in the comments. See you around.